Hi guys. Today we are asked to minimize this function f of x equals tangent 1 plus tangent squared of x over sine cubed sine cubed of x times cosine of x. So, and x is between 0 and pi over 2. So, first off, let me see, can I put this in? Okay, I'm going to unplug my keyboard. That's fine. Okay, so first off, since all of these are functions of angles, we can rewrite this, our domain, as, not rewrite it, but show it as this circle. No, not that. As this. So cosine and sine are always going to be positive, so is tangent. So all of our terms are going to be positive. So our minimum value is going to be positive. We want to maximize sine cubed and cosine and minimize tangent. Okay, cool. Let's see what we can rewrite. 1 plus tangent squared, I believe you can rewrite. If we have x squared plus y squared is equal to r squared, we divide by x squared, we get 1 plus tangent squared is equal to r over x is not the cosine one. The cosine one is secant, so this is cosine. Oh no. The x one is secant, because it's weird, it's the opposite. So this is secant squared of x. So we could rewrite this as secant squared of x. So f of x is equal to secant squared over sine cubed times cosine. So secant is 1 over cosine squared. So down here we just have 1 over sine cubed times cosine cubed. Okay, so now we have this product sine cubed times cosine cubed. How do we minimize this? Well, I mean, I think it's in the middle of sine and cosine. I think it's x is equal to pi over 4. That's the only, like, one of the extrema that are in the domain, between 0, pi over 4, and pi over 2. So if we try this, we get 1 over cube root, 1 over root 2 cubed times 1 over root 2 cubed. So adding them, we get 1 over root 2 to the 6th, which is just the square root of 1/2 to the 6th, so it's 1 over 1/2 to the 3, which is equal to 8. This could very well be the maximum. I'm not sure. Well, this function is probably going to look like this. It could also very well look like this. Oh, what we want to do is, if we want to minimize this, then we want to maximize sine cubed times cosine cubed. So I think we just did it. But another thing we could check is the function either looks like this or this, where this is pi over 4. So I'm going to check. Let's try x is equal to pi over 3. Then we get 1 over pi over 3. Sine of pi over 3 is 1/2. And then cosine is root 3 over 2. So 1 over 1/8 times 3 root 3 over 8, which is equal to 64 over 3 root 3. So, which is equal to, like, it's like 64 is about 63, so we're going to say 21 over root 3, which is about 21-ish. So we can clearly see 8 is larger, and this supports, or 8 is smaller, and it supports this function, because if we take this point here, this is larger, and since it's continuous, it will be like that. So I'm saying 8 is our minimum value. So let me check. Sorry guys, I'm currently checking the answer. This is 8. 8 is 8. Cool, I got it correct. What they do, they simplified it to what we got. The denominator is... Oh, it's sine squared cosine squared to the 3 over 2. Which means, and I'm using sine squared plus cosine squared equals 1. It's max when they're equal. I don't really know how they got that, but I just used intuition. But, we did pretty much the same thing, but they used some kind of formula. And I got it correct. Thank you guys for watching. I'll see you guys tomorrow. Good.